While dealing with the condensers, you see, spherical condensers have very peculiar role. When it comes to spherical condensers, we have two types. But prior to that, you must know what is a spherical condenser. Whenever we have two concentric spheres and they are not in contact with each other, only then we might use the term spherical condenser. Now, you are having two spheres, these are concentric. In that case, you see, both are not in contact. You have the option either you ground outer sphere or you ground inner sphere. Depending on that thing, we have two categories. One is outer earth and the other would be inner earth. Earth simply means grounded. Here in the first type, the outer sphere has been grounded. There are two spheres. This has been grounded. It has the radius r2. It has the radius r1. Suppose the charge given is here plus q to the inner one. Because of induction, you see, we have considered here metallic sphere. So, by the method of induction, equal amount of charge will be produced that on the bigger sphere. At the same time, the remote end is going to have same amount of charge, but that will leak to the earth. So, it is no more there. Now, what remains here is a system of two charges plus q and minus q. You know this sphere is grounded. Obviously, the potential on it is going to be 0. This is a kind of universal truth we can say that whenever you ground anything, any object, any conductor with the earth, the potential is going to be certainly 0. Charge was given to inner one plus q. Let's see the potential on outer sphere because of two things. One, inner sphere, it will be q upon r2. Why r2, why not r1? Because the distance of this point from the inner sphere, that is from the center of the inner sphere, is going to be r2. And because of this one, it's going to be q upon r2. That way, it is equal to 0. Let's see the potential on the inner sphere. Inner sphere, because of a small one, it will be plus q upon r1. That because of outer one, it's going to be net potential is q. You take LCM, find r2 minus r1 upon r1 r2. You see the potential difference that we are going to represent by the letter V itself. It's going to be V1 minus V2, and since this is equal to 0, it becomes to V1 itself. So, V1 we are going to consider as a potential difference between the two. And capacity, you know, is Q upon potential difference. That way it becomes, you see, you find out Q upon V1 from here. You'll have the relation Q upon V1. You have the relation R1, R2 upon. This is the capacity of a spherical condenser when outer sphere is earthed. But this is an CGS system. For converting into SI, you have to multiply it by 4 pi epsilon naught. Now we'll switch over to the electric field between the space. Between the two spheres, we are having the space. Electric field here is going to be radially outward. It will follow inverse square law, but it's not going to be uniform because the field by the inner sphere will obviously depend on the square of the distance. You also know in between the two spheres, the outer sphere is not going to produce any kind of electric field. if you calculate, say, the ratio of surface density, sigma 1 upon sigma 2. Surface density, is charge upon surface area. By using this relation, charge upon surface area, you'll find it gets cancelled. Both are oppositely charged. So this relation is given. It's minus R2 upon R1 whole square. Let's switch over to another type, that is inner sphere being grounded. Inner sphere is grounded here. This is connected with the earth. Its radius of the other one, R2, R1. Now we are going to give the charge. There we used to give the charge to the inner sphere, and here the charge will be given to the outer sphere. Then directly you can't predict what amount of charge is going to be induced on the inner sphere. Just suppose it is Q. Remember, the inner one has been connected with the earth. I told you in the last discussion that when some object is connected with the earth, potential will certainly be zero, but it's not the case with the charge. It may have charge, negative, positive, or even zero. So we have to find what amount of charge is induced on this inner sphere. Knowing that potential must be zero, it can't be deviated. Let's calculate the potential on the inner sphere. This potential will be, because of the inner sphere, Q upon R1, and that because of the outer sphere it's going to be Q upon R2, and that should be zero necessarily. That way you find Q equal to minus Q you see it is substantial amount of charge, but you can't say that it is equal and opposite. At the same time, one thing extraordinary you are finding, that the inner sphere is connected with the earth, but at the same time it is having negative charge over it. Suppose you want to find the ratio of surface density of the two. As in the last case I calculated, you can put the values of their surface density, and ultimately you are going to find this to be R2. It's given over here, R2 over R1. Here the inner one is negatively charged, outer is positively charged. So the electric field is going to be radially inward. It's radially inward. Again, it will be non-uniform. It will be following inverse square law, and it will be having the direction towards the center. Now, finally, let's find what is the capacity in this case. Potential of the inner one is zero. Let's find the potential of the outer one. The outer sphere will produce the potential, this one. Inner sphere will produce the potential. You take Q, R2 will be common, and this R2 is also common, taken outside. Put the value of this small q, this is Q R1 upon R2. That means V2 equal to Q upon R2. This will be R2 minus R1, here R2. You see, as in the previous case, V2 is having this value and V1 equal to 0. So V2 minus V1, that is 0, that is the potential difference. V1 itself is 0, that's why we can say V is equal to V2 itself. And for finding capacity, you'll use Q upon V2. That will give you the relation R2 square upon R2 minus. This is the capacity in CGS system when the inner sphere is Earth. If you compare the capacity of both the types, you'll get the ratio. This is given here, C in upon C out. That means when inner is earth, when outer is earth, you have the ratio R2 by R1, and you know R2 is greater than R1 in our considerations. That's why we might say that C in is always greater than C out. But at the same time, we must be careful. This is one of the rare type. C out is most common and it is most practical in our life.